Okay, let's first talk about what matter is. Matter makes up 4% of the universe. So when you look around the room, you are looking at matter. So the definition of matter is anything that has mass and it takes up space. Now, the ancient Greeks in 450 BC had a concept of what matter was composed of. So they said that if you had a piece of metal and you hit it with a hammer, you could break it up into two pieces of metal. And if you keep hitting it with the hammer, eventually you would get down to something that could not be divided anymore. And so they called these things atoms. Then in 1800, a guy by the name of John Dalton, a chemist, reinvented this idea, and he used it to explain chemical reactions. But he thought of atoms as being like billiard balls. And so somehow these billiard balls would connect to each other to make molecules and then to make chemical reactions. So it wasn't until about 1897 that J.J. Thomson discovered the electron, a negatively charged, teeny tiny little particle. And so what he thought that an atom was a uniform positive entity that had sprinkled in it these negative electrons. So it was a step forward. So at least he realized that an atom had a positive part and it had a negative part. But it wasn't until 1911 that Ernest Rutherford showed that an atom had a nucleus where the positive charges resided, and then the negative electrons formed a cloud that surrounded the nucleus. And then James Chadwick in 1932 discovered the neutron. And so he discovered another particle that lived in the nucleus along with the protons that had no electrical charge. And he called this thing the neutron. Well, along comes atom smashers. So now this is in the 1930s, and they discovered that you could make a charged particle go faster and faster by using an electric field. So that first picture there shows two plates, and one plate is negatively charged and the other plate is positively charged. Okay, and then what we're going to do is take a electrically charged particle and put it in there, and then it's going to be repelled by one of the plates and it's going to be attracted to the other plate. So it's very similar to, there is a gravitational field in this room, and if I take this thing and I let it go, so you notice it's following the direction of the gravitational field and it is accelerating. So by taking two charged plates and putting your electrical charge in there, it would be repelled by one of the plates and attracted to the other plate, and it would start to accelerate. Well, if you had a series of plates, so you'd have a plate here that would cause this electrically charged particle to go over to here. Now, let's say that the charged particle that you are interested in is a positively charged particle. So then that would mean that this plate over here would have to be positively charged. And then it would go in this direction. And then this plate would be negatively charged. Well, imagine that as soon as the positive charge gets over to here, we could magically change this plate from being negative to positive, and then we put another plate over here that is going to be negatively charged. Then what would happen is this charged particle would continue to move, and it would go faster and faster and faster. Then they got the idea, well, what would happen if we took this straight line and we turned it into a circle of plates? So you got all of these plates like this going around in a circle, And then every time that the charged particle got to another plate, it would reverse the polarity of the plate, and it would go around in a circle, and it would go faster and faster and faster and faster. So these were called atom smashers. Today, we call them particle accelerators because they're accelerating the particle. The reason why it goes around in a circle is because of magnetism. So I can't really explain this, but by using magnetic fields, you can bend the trajectory and you can make it go around in a circle. So the circle have gotten bigger and bigger and bigger because the bigger the circle, the more powerful the particle accelerator is going to be. So it says that the circle at a scientific laboratory on the border between Switzerland and France is called CERN, and the circle is 8.6 kilometers across. So it's just a gigantic circle. Now, the actual thing, the tunnel that the charged particle is going through is about the size of a fire hose. It's about this big around. Okay, but surrounding that is a whole bunch of machines that are designed to capture and photograph the particles that come flying out when these particles collide with each other. And so that picture, the lower picture over there to the left, shows you the inside of the tunnel. Now remember, the thing that's actually carrying the particle is about this big, but it's surrounded by these gigantic computers and machines that are going to photograph it. And so if you look closely at that picture, you'll see a person, a teeny tiny little person, standing at the bottom of it wearing a hard hat. So that gives you an idea for how big this complex is underneath the ground. And then finally, you have an actual picture of what happens when a positron, or a positively charged proton, hits an anti-proton. And we'll discuss that in just a moment. What do we mean by matter and antimatter? But when a proton strikes an antiproton, lots of particles come flying out of the explosion, and that's a picture of those particles. And then based on how much the particle curves when it comes out of the explosion, we can figure out the mass of that particle. And depending on the direction it's going, we can figure out the charge on the particle. And then if the particle goes in a straight line, then that means it's not being affected by magnetism, so it must be a electrically neutral particle that would be making that particular trajectory. So I want you to watch this little video here. How does an atom smashing particle accelerator work on YouTube? Okay, so hopefully that kind of helped explain some of the stuff that I've just been talking about. All right, so what were the results of these atom smashers? So they found out that there were hundreds of particles that came flying out of these explosions. Now remember, the whole idea of doing this in the first place was to make things simpler. We wanted to find out what are the ultimate particles that make up matter. So the ancient Greeks, how many particles did they have? One. So they said one particle makes up matter, and they called it the atom. Then later we found out that there were negatively charged particles, electrons in there. Then we found out that there were protons, and then we found out that there were neutrons in there. So now we're up to 3 particles that makes up matter. And then when they started smashing atoms together and nucleuses together, they found out that there were even more kinds of particles. Now, you're not going to be responsible for knowing some of these names. Now, I do want you to know what a lepton is, and notice that the ordinary electron is an example of the lepton. And then I'll explain what a neutrino is in just a few moments. So those are the very lightest particles in the known universe. so the electrons and the neutrinos, and we call those leptons. Then the second largest particles are called the mesons, which don't worry about that name, don't worry about those particles, but there they are. And then you have nucleons, such as the proton and the neutron. So you know what a proton and neutron are. So those are called nucleons. And then there were hyperons. And so these are even bigger particles that came out of these explosions. So the question was, what was causing this to be? Okay, so let's take a break, and when we come back, we are going to discuss what quarks are.